Alright, so this is the video key solution for problem set number 2 in your unknown angles packet. Alright, so before we begin, let's read the directions. It says use your transversals notes to work on this problem set. And again, you finished your transversals notes today in class. It says find the unknown labeled angles and give your reasons for your solution. Okay, so first thing I see right here in this picture is I see a circle, and it goes 310 degrees. Well, it's not a complete circle, but it's part of a circle. Well, I know a full circle is 360 degrees, so this right here must be 50 degrees. Now, if I were to draw an auxiliary line, my third parallel line, okay, this line is parallel to this one, and it's also parallel to that one. And this right here must be my transversal cutting through both the lines. I notice that this angle and that angle are both on the interior or the inside of my two parallel lines. And I notice related to the transversal that they're on alternate sides or opposite sides of my transversal. With that being the case, we know that alternate interior angles are congruent. So since this is 50, this too must be 50 degrees. So the measure of angle A is 50 degrees. And the reason we know that is because alternate interior angles are equal in measure. Okay? Number 2, we need to find the measure of angle B and the measure of angle C, and then give our reason why. Now, looking at this, I see that B and C are inside of a triangle. And thinking of triangles, I know that triangles measure 180 degrees. 180 degrees. So with that being the case, and this being our parallel line, we see that this line is parallel to that one, right? So I'm going to extend this top parallel line out so that we can really see it. There's our line, and then here's our other line right here. Okay, so those two lines are parallel. These two are parallel. Now, when I see 46 and I see C, and this of course is my transversal right here cutting through them, I know that they're both on the interior or the inside of my two parallel lines. And related to the transversal, they're on alternate sides or opposite sides of the transversal. So since we know that alternate interior angles are congruent, C must be equal to 46 degrees. Okay? 46 degrees. Now, we need to find B. Okay? We still need to find angle B. And so, again, this is our transversal cutting through our two parallel lines. So we're no longer paying attention to this transversal right here. We're now paying attention to this transversal right there, cutting through our two parallel lines. Now, this angle plus this angle plus this angle have to equal. Alright, question number 2. I see my two parallel lines right here, so I'm going to extend them out. Okay, and I see a transversal right here cutting through them. Okay, so two parallel lines, transversal cutting through. Now, looking at 46 and C, I see that they're both on the interior of my parallel lines, and I see that they're on alternate sides or opposite sides of my transversal. So since they're on alternate sides and they're on the interior, that means that they are alternate interior angles. And we know that alternate interior angles are congruent. So if this is 46, this too must be 46 degrees. Now we still have to find angle B. Alright, we still have to find angle B. So I'm going to erase everything I've done so that we can see the other numbers and see what we can do with those in order to find angle B. Now I'm going to focus on this little point right here. And I notice that this angle right here is 94 degrees. And this angle right here is vertical to this angle. So since we know that vertical angles are congruent, if this is 94, this side over here too must be equal to 94 degrees. Now, if you notice, they're already giving us 46 degrees right here. So this plus this must equal 94 degrees. So 94 minus 46, 14 minus 6 is going to be 8. 8 minus 4 is going to be 4. So this right here must be 48 degrees. Alright? Now, I'm going to extend this parallel line again. Okay? And remember, vertical angles are congruent. So if this is 48, this 2 over here must be 48 degrees. And if this is 46, this 2 over here must be 46 degrees. Now, let's use that information to figure out what the measure of B is. So I'm going to extend this top parallel line again. Okay? And now we're going to use this line over here, this side of the triangle, as our transversal. Okay? Now, noticing that 48 and B, angle B, are both on the interior or inside of my parallel lines, and they are on alternate sides of my transversal, they must be congruent. So angle B is 48 degrees. Now, how did we figure all of that out? The first thing we did was we knew that alternate interior angles are congruent, and we also know that vertical angles are congruent. Okay, those are the two definitions we used. Alright, number 3. Alright, number 3. We need to find the measure of angle D and angle E. So let's see what we got. Okay, so we have two pairs of parallel lines. We have these right here, and then we have these right here. Alright, so really where we start doesn't matter, as long as we start with one of them. Alright, so I'm going to use, alright, number 3. We have, I see, two sets of parallel lines. Here's our first set, and here's our second set. So I'm going to focus on the one that only has the one arrow right there. I'm going to focus on this first set of parallel lines. Okay, and I'm going to draw them out. Okay, and again, I know these two are parallel to each other because they both have one symbol right there. So this is parallel to that. Now, this right here has to be the transversal. Alright, so let's begin. What I notice right here, this top parallel line, I see the 122. And I know that this, all the way to that, since these two angles are on the line, must equal 180 degrees. So I'm going to subtract 122 from 180, and I get 58 degrees for this one right here. Okay? Now, using that, I'm going to use this and put it over here because they are alternate interior angles. They're on alternate sides of our transversals, and so I could put the 58 degrees right there. Now, looking at this bottom line, I know from here all the way over here, these three angles must sum up to 180 degrees. So I have 58 and 72. 7 plus 5 is 12, plus 1 is 13. Okay? So, together right here, I have 130 degrees. Well, if I add this one to it, it must equal 180, so D must be 50 degrees. Okay? Now let's focus on the other two sets of parallel lines. So I'm going to erase all of this so we can focus on finding E. Alright, and I'm going to turn my page so that those two parallel lines are facing me. Now I'm going to leave D here. D we found as 50 degrees. Okay? And I'm going to draw out these two parallel lines. So this line is parallel to this line. And with that being the case, this right here must be the transversal. Alright, now 50 plus 72, and this angle must equal 180 degrees. Alright, so since that's 50 and that's 72, we need to find that. So 50 and 72, I get 212. I'm going to subtract it from 180. Okay, so this right here must equal 58 degrees. Now, I see that E and this angle right here, the 72 plus 58, are on the same side of my transversal. So they're same side interior. So I'm going to add these two up. Okay. And I know this one plus this one, same side interior, say that they have to be supplemental, which is 180 degrees. So if this right here is 130, then this right here must also be 50 degrees. Okay? Now, what reasons did we use to figure that out? Okay? The reasons we used was that linear pairs of angles are supplementary, and we also use the fact that same side interior angles are supplementary as well. Alright, last question, number 4. As I look at this picture, specifically this quadrilateral right here looks very specific or very familiar to me. I notice that the alternate sides are parallel to each other, which makes it a parallelogram. Okay? Again, the definition of a parallelogram is alternate or opposite sides are parallel. Okay? Another special feature about parallelogram is that opposite angles are congruent. So this is congruent to this, and that is congruent to that. Okay? So my goal is to find the measure of this, and since these two are vertical angles, they too are congruent. Alright? So let's go ahead, and I'm going to focus in on these two parallel lines. So this line up here, and this line down here. Okay? So I'm focusing on these two parallel lines. Now, I'm going to use this side as my transversal. Okay? Now, since I have these two angles, these are the two I'm going to compare. If this is my transversal, cutting my two parallel sides, I notice that these two angles are on the inside of my parallel lines. Now, not only are they on the inside, but they're both on the same side of the transversal. So they are same side interior. Now, just like in the previous problem, I know that same side interior angles are supplementary. So, what does that mean? That means that this angle plus this angle has to equal 180 degrees. Alright? So 4x minus 2 plus 3x plus 7 is equal to 180 degrees. Now, once I set up my problem, I'm going to combine like terms. 4x plus 3x is 7x. Negative 2 plus positive 7 is positive 5 equals 180 degrees. Now I'm going to subtract 5 from both sides. I get 7x is equal to 175. And when I divide both sides by 7, I get that x is equal to 25. Okay? Now, I'm going to take this value of x and plug it into this formula, because remember, this angle is congruent to that one. So 325 plus 7, 3 times 25 is 75. 75 plus 7 is 82 degrees. So this is 82 degrees, which makes this 82 degrees. And since these two are vertical angles, this too is 82 degrees. Okay? So the first thing we used was that same side interior angles are supplementary. The last thing we used was the fact that vertical angles are congruent. Alright, thanks for watching, and I'll see you in class.